So now let's look at what are these factors. So the first one is the surface area. For instance, if you take, so if you normally you take food, but when you're swallow, you don't just swallow it, but you chew it into small pieces and swallow it. But think, so let's take you're not going to chew it, you just swallow it. So what happened? The whole piece of food is going to your stomach. So in the stomach, as I mentioned, you have a lot of enzymes and HCl. So this HCl and the enzymes just touch only the surface area of that piece of food. So the inner parts won't touch the touch those other reactants. So HCl is the other reactant. So or the enzyme is the other reactant. Or the catalyst. We'll look at a catalyst at the latter part of this lesson. So what happened? Only the surface will be touched by those other reactants. But if you chew it and swallow, what happens? So the piece of food will be chopped into small pieces, and each and every small piece will be touched by the other reactant. So what will happen? So the digestion will be very fast. So because this, when you chew it, what happens? The surface area becomes high. So if you take a piece of soap, so let's take it's like a cube. What will happen? So you just it's one. We'll say it's 10 centimeters. 10 centimeters. So the surface area will be, it's a cube. So you get the surface area of this face and this face, and altogether 6 faces are there. So it will be 10, 10, 10 into 10, 100, and 100 into 6, 600 but square centimeters. But if you cut this piece of the cube of soap into small cubes like this, like 1 centimeter cubes, what will happen? So if you so this 10 centimeters will be divided into 10 parts, and that means 10 cubes you can obtain 10 cubes. If you calculate the surface area of one of these cubes, it will be 1 square centimeters, and into so if there are 6 spaces, normally there are 6 spaces per cube, so it will be 6 square centimeters. And so how many cubes are there? How many cubes can occupy this large cube? So it will be 5 into this side and 5, so 10 into this side and 10 into that side. That is no this phase, it will be 2, 3, 4, 5. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 5, 10, 15, 20, 25, right? So 25 cubes. So that will be 6 into 25. So likewise, there are how many lines? Here also there are 1. So this layer is gone. There are another 4 layers. 1, 2, 3, 4, 5. Right? So that means another 25, right? 25 into 5 means 125. 750 square centimeters. That means you have 25 layers. So just draw and see, right? So the surface area will be, if you calculate just the 10 centimeter cube, that surface area of the of all, when you add the surface areas of all six faces, it will be 600. But if you cut into small 1 centimeter cubes, you will end up with 750 square centimeters. Right? So that means when the surface area is large, the the reaction rate will be high, because there are more surface area to collide with the other reactants. So I told you that this the rate of the reaction depends on the collision of the reactants. So they can collide with each other very efficiently when the surface area is high, right? So when you just have the piece of stove or piece of food, only the outer surface will be touched by the reactants, the other reactants, and when you chopped it or you just uh, when you chew it and swallow it, each and every single part can be touched by the reactants or can be collided with the other reactants. So the other very important factor is the temperature. So when the temperature increases, this collisions increases, because the particles, so if you take these molecules, just uh, they just move, no? So it's a solid. When you heat it, they have these vibrations. So what happens? These molecules are vibrations, and they if you take a liquid and a gas, they are in a liquid the particles are a little bit far away to each other, and if you take a gas, particles are like this, and they move everywhere, right? So these movements become high, and their speeds become high. So the probability of having collisions become high. So that's why when the temperature increases, the rate of the reaction increases. And when the temperature decreases, the rate of the reaction decreases, because the collisions become low. And the other one is the concentration of reactants. So concentration means the amount of that molecule. So if you take a drink, soft drink, or a cordial, so you know when you're preparing a cordial, you put some amount of cordial, and you put some when compared to the cordial, you put a lot of water. So what happens if your water, uh, the amount of water is very high? I mean very high than the amount of cordial. So it will be it will have the taste of water. Right? So that means the concentration is low. The amount of cordial concentration is low. So what happens if you put less amount of water and more amount of cordial? The concentration of cordial is high. So what happens in, so that's just an example. So if you take like that, when you have lot of reactants, when the concentration of the reactants are very high, there are so many, there can be so many collisions, because there are enough of molecules to collide, right? So if the amount of reactants are very low, the collisions are very low. Why? The one molecule have the probability of getting collided with several molecules. But if the concentration is very low, sometimes one molecule can collide with only one molecule from the other end, right? So when the concentration is high, the rate of the reaction becomes high, and when the concentration becomes low, the rate of the reaction becomes low. And the final one is the presence of catalysts. So catalysts are actually the catalysts. I'll explain. I'll give examples for these factors. Let's look at catalysts. So actually, catalysts are chemical compounds, another chemical compound, but it is not a reactant. It doesn't participate in the reaction. So finally you can get, so if you put lead for some reaction, you can get lead as it is, right? So it doesn't nothing happens to it at the end of the reaction. So catalysts are the substances. The only thing is that they increase the rate of the reaction, right, without being chemically consumed. So catalysts are the substances that increase the rate of the reactions without being chemically consumed during the reaction, right? So let's look at examples and small practicals for these factors.